So here we are. My name is Mr. Jackson,
I'm Miss Hughes.
and we are looking now at our next unit in statistics, which is the measures of central tendency. So how much or to what extent data will cluster towards a central value.
And in the last unit, we looked at how to collect and organize data so that we've organized it into charts, and then visually presenting it in like histograms or using polygon or pie graphs. But in this unit and the next unit, we're going to look at how to analyze it. So you know how it's collecting, organizing, analyzing, and presenting. We're going to look at analyzing one variable in this unit and then look at seeing the connection between two variables in the next unit. So we're going to break it down into parts for one variable statistics. We want to look at, what are the central values or the middle values or the values that are repeated the most, and that's measures of central tendency. Next, in the next unit, or in the next lesson, we'll look at dispersion or how spread out they are. So we want to look at the central tendencies for this lesson, and then we'll look at how spread out it is for the next one.
So we should say that in the first two lessons in this unit, we've divided our measures of central tendency into two parts. First, we're going to look at ungrouped or just raw data and how to measure the median, the mode, and the mean for ungrouped or for raw data, both by hand and using Excel.
Yep.
And then in the second lesson, we're going to look at the measures of central tendency, but the second part being weighted means and what do you do, how do you calculate a mean when you have grouped data or data that you've put into intervals?
Yeah, so it's already in the table, the frequency table, and you don't have the original data point. So that'll be actually lesson 2 when we look at group data. But for today, we're going to say, let's say that you've got all the raw data that was collected, all the raw data points, and you want to find the measures of central tendency. The central values are the values that are repeated the most. So the median, we'll just start with the median here, the three most common. The median is the middlemost value of the data. So it's key that it's ranked in order from lowest to highest or highest to lowest, doesn't matter, but it has to be ranked in order. And so to find the median value is the middlemost value. If you've got an even number of data points, then let's say you've got 80 data points. If you cut 80 in half, then 40 data points will lie below your median and 40 will lie above. But if you only have 80 data points, then how do you figure out what that middle value is? You take the 40th and the 41st and you add them and divide by 2. So you average the upper value in your lower half and the lower value in your upper half, the 40th and the 41st data points, to find that middlemost value, like a balance point or a fulcrum, where half your data is below it and half your data is above it. That's the tricky one. If you've got an odd number of data points, then say you've got 15 data points, well, then one of them will be the fulcrum, will be that balance point. So if you subtract 1 from 15 to get 14 and then divide that by 2, then you know that you would have 7 data points below, 7 data points above. So that means your 8th data point in would be that balance point or the median. Yeah.
The mode, so actually here's a quick little example, just exactly what you were saying. If I've got the data set 1, 1, 2, 4, and 7, the median for this set of data would be 2 because it's the middle point of the data. But as you were saying before, if I have, say, 1, 1, 2, and 4, what's the median of this data? Well, there is no middle datum.
Yeah.
So what we need to do is we take the 1 and the 2 and we average them together, and it's 1.5 is the median.
Yep. So we have to generate that middlemost value if you have an even number of data points. That's the only trick for finding the median. Got to go in order and got to find the middlemost value.
So the mode, then, is the value that occurs the most frequently. Okay? So when you have a set of data, and you have, usually in very large sets of data, what's the most commonly seen value? What's the most frequently occurring value? It is important to note that there can be one mode, there can be no mode at all.
If every value is unique.
Yeah, and there can be more than one mode.
Yeah, so you can have more than one value that's tied for mode. So like, just to clarify, if you had one value that was repeated 5 times and a different value that was repeated only 4 times, then the one that's repeated 5 times is your mode. Okay, but if you had 2 values that were both repeated 5 times, then you have 2 values tied for mode, which means that you actually have 2 modes.
Exactly.
Okay. Yeah.
The mean is basically another word for average. And it's the sum of all the values in our data set divided by the number of values in the data set.
Yeah.
So it's basically, when people talk about what's the mean of the data, really what they're saying is what's the average.
Yeah.
An extra element that we would really need to consider is that some distributions, some sets of data have what we call outliers. And these are values that are very, very distant from the majority of the values. Okay, we will learn how to classify outliers later.
Yeah, there are calculations we can perform to test if a point is an outlier.
But really, what's important to note now is that outliers will have a much greater effect on the mean than they will on the median. Which is why for many data sets, both the mean and the median are given and reported.
And in fact, if you notice on your report cards, they do class medians now.
Yes.
They don't show the mean.
Yeah.
And that's to offset, you might have students that never attend, so they have 12%, and that greatly affects the class average, but doesn't affect the median as much. So you'll notice your report cards have medians now. They used to be means when I was in school.
Yeah, yeah. Me as well. Determining which measure to use is sometimes tricky. So here's a couple of guidelines.
So because outliers affect the mean the most, especially if you have a small sample size, if you only have 20 or 30 data points, in general we use the median if the data contains outliers, and especially if there is a small sample. If it's mainly symmetric, so you have just about as many below and above the mean, and they're sort of matched left to right in terms of the way that they're distributed, then either one is appropriate. With an E on the end of the word appropriate, lost an E, or use the mode when the frequency is more important. So if you were ordering shoes at a shoe store, you wouldn't be so concerned with the average shoe size ordered. You'd be more concerned with, well, which shoe size is purchased the most, and that's what you'd use to replenish. So there are times when mode is what you care about more. And especially for non-numeric things, categorical things like hair color or favorite sports team or whatever, then you might be more concerned with the mode, the ones that appear the most frequently.
Yep. Okay, so let's look now at basically how do we calculate means and using mean values. So we can distinguish the difference between the mean of a population and the mean of a sample. Okay, and so really the distinction is mainly just in the symbols that we use.
It is, yes.
So let's take a look first for an entire population. The mean we call mu, which is a Greek letter, and there it is right there. And so for a population, we would add up the value of each individual piece of data, and then we would divide by the number of pieces of data.
And so the symbols that you see here, x sub 1 plus x sub 2 plus so on and so on, all the way to x sub n, just means that the nth data point, so say there are 10 data points in your whole population, pretty small population, then you'd add up each of those 10 data points and then divide by 10. So the nth data point, which is the last one you add up, that's the number of data points, and that's what you divide by. And we use capital N and mu to show that it's the population, and because the sample is always just trying to estimate the population, it's important that when people are reading your results that they know, is this population mean, or is this just the mean for your sample and we're trying to approximate a population from it?
And for our purposes in this class, it may not be crucial all the time, but in research this is very, very important. Very, very important. Now for those of you who have taken functions, even functions at the grade 11 level, this notion of summation notation has been introduced. And this large, what looks like a stylized E, is actually the symbol for a sum.
Yeah, it's Greek sigma and it's capitalized.
Yeah, it's a Greek capital sigma. And so what this summation notation tells us just very quickly is that you have all these elements of the data set, and we call those xi. And really what we're going to do is we're going to add up all the different xi's that run from the value 1, so the first data point, to the value n, the nth data point. And then we're going to divide by the number of data points. So this is just a very compact way of writing this right here. When we look at a sample, usually we use small n to denote the number of elements in that sample. And here we would have, of course, a very, very similar, only different in notation, formula for sample mean.
Yeah.
And then, of course, here's the summation notation for sample.
And note that that little symbol there is called X bar. And
Yes.
so when you're doing in Excel, there's no way to put X bar in there easily. So then you'll just type in XBAR, X
Yeah.
bar. And for mu, you can either put in MU or you can just put a little lowercase u, and we'll know what you mean, right? But yeah, for this, X bar is for the sample and mu is for the population.
If you choose a wise sampling protocol, i.e., remembering from last unit measures of basically sampling techniques, how to sample properly,
Yep.
and there's no bias, there's no survey bias, your mean will approximate the population. So the mean for your sample will approximate the mean for the population.
Yep, and that's the goal.
All right, so here's an example. 2 classes wrote the same physics exam and had the following results. So here's the data for class A and for class B.
Yep.
And so what we want to do now is we want to manually calculate the mean, the median, and the mode for each class. We want to use these measures of central tendency to create some kind of a discussion. And we want to see, are there, first of all, are there any data points that we might consider at this point to be outliers? And how do they affect the mean and the median?
In each case, yeah.
So we're going to go ahead and we're going to do class A together right now. Class B will simply report the results. So after we finish class A, you may want to pause it,
yeah.
do it yourself, see if you get the same answers as we do. So here's class A, and the mean, first of all, we should note we have 17 data points. And so what we're going to do is we're going to take each of these data points, we're going to add them up, and we're going to divide by 17. Okay, so here we go. Basically what you're going to do is you're going to say 71 plus 82 plus 55 plus 76, blah, 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 plus 51 plus 68, divide by 17, and of course the answer that we get is 71.5. Okay, so the mean for class A was 71.5. The median, though, we need to do something first.
Right. So you notice the data 71, 82, 55, 76. It doesn't go in order from lowest to highest or highest to lowest. We tend to think in terms of left to right and top to bottom, so it's easiest to put it in order from lowest to highest. So first thing we have to do is reorganize all that data so that we have the lowest point on the left, the highest point on the right, and then it's an ascending order as we go from left to right. Once we've done that, since we know we have 17 data points, that's an odd number, I take out, in my mind, I take out the data point that I think is going to be the middle one, which brings me down to 16. When I divide that by 2, I have 8, so I know there should be 8 data points on each side of my median, so that means that my median is going to be the 9th point in. So we just kind of count 1, 2, 3, 4, 5, 71, there it is, perfect.
Yep.
So that's going to be the median because there are 8 data points below, 8 data points above, and it's the 17th data point. You know,
okay, so the median for this set of data is 71.
Yep.
And the mode, coincidentally, if we look at this set of data, we notice that 71 appears 3 times.
And that's another handy thing about putting it in order from left to right in order to find the median, is now all the like data points are grouped together. So the 71s are all together. You know, if there are any other repeated values, which in this case there aren't,
no.
they would be together, they'd be clustered together. So it's easier for you to catch the mode or the modes, if there's anything tied for mode, by putting it in order from left to right, in ascending order. Yeah.
All right, so now class B. And these are the values that we got. At this point, maybe press pause and try and work out these values yourself. If you're not interested in doing that, then we'll just continue right on. But this would be a good time for you to try your hand. It turns out actually with class B there are 2 modes, 61 and 80.
And 80, yep.
The median is 71 and the mean 64.4.
And the previous mean was 71.5. So this mean
Yes.
is lower.
Is much lower.
Much lower than class
More
A.
than 10%.
Yeah.
So now, you know, we've actually looked at, you know, calculating mean, median, and mode, but let's compare their performances. So in this case, we could look at the median and we could say, you know what, both classes have very similar performance as indicated by the median.
Yeah.
However, the mean suggests something quite different. The mean would suggest that Class A has much better performance than Class B.
And now this may be the case, but we know that there are a few really low values that existed for Class B, and those might have been students, again, non-attenders,
Yeah.
or something else going on in their lives, who knows, but for some reason those kids were not anywhere near passing.
Yeah.
And so those couple of really low values will pull the mean down, but as we discussed earlier, don't affect the median quite as much.
So really, when we look at that overall, we would say that, yeah, really, the performance of those two classes is very, very similar.
Yeah.
And the median, because they're small sample sizes,
Yeah.
and because the one class had two significant outliers,
Yeah.
or what we assume to be outliers, we would say we should probably use the median to judge. And in this case, the median is very close, and so we would say their performance is very
Very
similar.
similar, yeah.
All right, let's take a couple minutes and do the exact same thing, but now using Excel.